of the bulb as well as how the longevity of the bulb in a certain interval of time. And he came up with this formula right there, which you guys already hopefully have an idea what each portion of part is. The E we know is an irrational number, the lambda is the average, and X is just whatever we put in, like exactly 4, 3, 7, integer numbers. Mr. Apple.
I've seen lambda in physics before.
Yes, lambda would be what in physics?
Wavelength?
Correct, yes. Okay. And when we talk about the higher math classes and so on, it's also used in Lagrange multipliers and the Jacobian, which I won't go into. All right, that was my torture. All right. So this guy, actually, his stuff was published in 1837, and then it went, absent. And then around 1898, this one guy, Van Bros, I can never pronounce his name, so I just say Van Bro. Okay, that's what they say. They say VB. He came up with this idea since he was using this Poisson distribution to find out where the artillery shells would possibly hit, and it was even used in World War I. You remember Harbor process, the guy that made up mustard gas? Well, he also was there on the German side, and then he was with the Prussian, in like the Euro-Prussian War, I think it is, so later in the 1860s, with Van Brunswick and so on, if you remember your German history. I only do, because that's just me. So he was tasked to do this idea to find out how many soldiers would get killed by horse kicks. I'm not kidding, this is a true story. You could look it up, Billy, if you bug me, and I'll get this to you as well, right? And it talks about this man, he's right here. I was just going to show it on the thing. Oh, hello there. Okay. So what he found out after a 20-year period, there was a total of 200. And what he observed in that 20-year period, there was 122 that actually died from getting kicked in the head. Not survived, died, dead, boom, dead. Whether it was at war and everything else. So he had read reports, he was with some of the Army Corps and everything else. They were called corps or battalions back then. There's still battalions today. So he figured out lambda, which is 0.61. Well, if it was 1, that means everybody died, right? So there'd be no Army Corps. So it had to be less than 1. Yeah, pretty obvious. So keeping going on, so since the deaths were 0.61, he used this formula and said to himself, well, what would it be if the Prussian army existed for 200 years? And then he compared that data, actually, to his 20-year span. And he found out that when E is 0, you're going to find out there was a 54% chance within his 20-year span, as well as in a 200-year span, that no one would die. There would be no possible deaths, and so on. All right? So he calculated all this and everything else. And the recording was near spot on to the expected value. So I did this thing over here, okay, because this, you know how I am. Predicted value because of the Poisson, and then the expected value, all right? I'm not sure if we're going to have expected value and stuff in here. We probably will, Emily, so I'll have to get on that as well. All right? So the expected value as well as the predicted value and so on. So what happened was there are no deaths, 54%. One death, 33% in a certain span, right? 2 deaths, 10%. 3 deaths in the same core, so to speak, less than 2%, and then that is 0.3%. And then 5 and 6 deaths, let's say within a class or something like that, or core, nothing. So he did this stuff within nearly a 20-year span. And what happened was they had the blue and then the green, which is the Poisson distribution. So we had the actual versus the theoretical by just using Poisson, right? So there was 91 for 1 death, and Poisson figured out 97. And then notice it's getting closer and closer, right? So what you're finding out that this is a hyperbola coming downward. It is skewed. It is not symmetrical like normal distribution, everyone. And it's similar using histogram fashion, finding out that 32, 34, 11, and 8, the numbers are what we consider to be covariant. So there is a correlation between these numbers. Whereas I don't have to wait 20 years to do the data. I can just plug some information in and be really close to find out what it was. No different than what Eratosthenes did 2,300 years ago, 2,354 years ago, sorry, figured out the circumference of the equator. And the circumference as well. They didn't believe, right? I know you got those flat Earth believers, right? They still believe the Earth is flat. I don't know what weed they're smoking and so on. I really don't. But they believe that the world is flat. But he proved just using a stick, and I told Mr. Epler to go walk from Syene to Crete, and then tell me how long it was, and then I figured out the shadows between the sun on two buildings. I know that's 7%. I believe that the Earth is an ellipse, hence a circle. I can use ratio proportion. He was, in the 1960s, if you saw Hidden Figures, they did a calculation, because there was the first American that was in space. They did a calculation. He was 98% correct. Not bad for some Greek in a toga, right? Versus what the technology that they even, now it's archaic compared to today. So you saw Hidden Figures, okay? So this just shows you the data that's associated with it. This is the table, okay? And then I did a picture, okay? I had period 4 and 5 here, and they wanted me to erase everything. I said, oh, no, go away. So I had to erase all of this, okay? All right. Not bad. So the Poisson has a good variability with it. It's very important, and I know, like, well, it's a math class, a stat class, and everything else. All right, so now here's where we're going to get to the meat and potatoes, right? Sammy observes births, at Wusthof Hospital that occur randomly. Yes? Oh, nothing. Okay, at a rate of 1.8. There we go. Yes, 1.8. We'll just go 1.8 births per hour. Sammy asks his beloved 34th and Pasmorians the following questions, because he can. He says, this is cat, right? He. What is the probability of observing exactly 4 births an hour? What would you do? Ask Murmer, right?
Use the formula?
That's correct. Okay, so we're going to use the formula, which I completely agree with. I'm going to write the formula down here. And we can use, be subjective with the variables. Yes? Okay, and x could be 1, 2, 3, 4. All right. Now, it says, do we have an average? And that average is going to be what variable? Yeah, and that's 1.8. What else do we know? And that would be the random variable, which is 4. Rocket science, right, guys? E to the negative what?
Negative 1.8.
I'll get out of the way, I'm sorry, okay? Times 1.8 to the 4. And this is P of x equals 4, right?
Yeah.
All magic.
No.
I just miracled it. God bestows these powers to me. Oh, no. Where I got it from, ma'am, is it says right here. 4 births. Tell me how many 4 births per hour that Sam's going to observe. Good question, okay? Ask, okay? Divide by x factorial, which would be what?
4 factorial.
4 factorial.
4 times 3 times 2 times 1.
Which is?
Something.
Something, yeah. 24, right? Remember 5 factorial is 120, you know? I'll start getting on them, don't worry, okay? No one asked me the question yet about, the big factorial thing. And then this is roughly, and then Billy's going to tell me what it is. Maybe. Now sometimes, guys, they write this as X, a little symbol like so, and then they write what's called, I call it the, you ever have a poi boy sandwich? Poi boy? Did I say it right? Wrong. Cuban sandwich? Poi boy? It has pickles. I throw the pickles out. The pickles, so I throw them out. It has ham, cheese. I throw the pickles out. I don't like pickles. I lived in Korea and had kimchi all over the place, and all these people smell like kimchi. It's gross. Yeah. You take kimchi, you take pickles, and you bury it in the ground for months, and then it has this horrific smell. Oh. So this would be just PO.
It's like stinky tofu.
Yeah, I'm not big on that either. Okay. Yeah. So what do we get here? What is it roughly? Oh. Okay. I'm working it. It's a really interesting example if you think about it, right? And then he applied it to if the Prussian army lasted for 200 years. And he found out that the data that happened in 20 years is no different than it's going to happen in 200. And he was relatively close. Can you imagine if you can estimate now in 200 years? Wow. It's like having today's newspaper for yesterday. Today's newspaper yesterday. So you do this calculation here. Remember, this is the numerator. I brought this up so he's negative, right? So this guy would be really down here, e to the 1.8, right, Michael? It's like, yeah, that's not. And Billy? How's that work? 0, 7, 2, 3.
Is there like
So
a
7%. I'm sorry. Okay.
No.
So,
Yes.
all right, not bad. I know you guys.
Lambda looks like a stick figure without a head.
He is a stick figure. Yes. I used to write cat heads, for salmon.
Wait, no, 7.
Yeah, that's correct. 7% chance for Sammy to observe with this type of data 4 birds per hour. Rocket science. Okay? About the two of them. Right? Not bad? Okay. Oh, stop, slow down. I always think I'm in the college mode, so I even go faster. I would be like this. I had this little South American woman, which was a brilliant woman. I worked with her when I was getting my, at the time, my master's in chemistry. I was going for my PhD in chemistry, and I switched, Michael. I should have stayed. I probably had my PhD in chemistry. But the biggest thing was I was working with her, and I was my second year, and she's like, she always talk like this. Yeah. So, and she would be like that tall and write monster equations. She had a step ladder to write equations all over the place. I had to have 4 notebooks just for a semester. I should bring them in. You'd be like, is this Egyptian? You know, all on quantum mechanics and something else.
This looks like Ryan.
And then there's another with statistical mechanics. I still have the book. It's about, I don't know, it's easily Ms. Adair that thick, okay? And I still have it to this day. All right, not bad. Okay, 7% chance. Sam says that's going to happen. Now here's another catch, right? What is the probability of observing that Sammy observes? More than, let's make sure I write it, of observing more than or equal to 2 births in a given hour at the hospital. More than. So we're looking at probability when X is what?
Greater than or equal to 2.
Right.
So we
Now.
0, 1, and 2.
That's correct.
And it's subtract from 1.
Yeah, you can, right. Because
it's more than.
it's more than, right?
So everybody's got numbers, right?
Yes, please, thank you.
Oh,
Go ahead.
so it's just 0,
Right.
1.
0 and 1.
Well, because there's no births, right?
Or there's
And there's 2 births, and then there's 3 births, right? So it's going to be 1 minus the probability. I'm right, yeah. X is less than 2.
Yeah.
Pretty good?
Oh, yeah, you
So
can do
it's
that.
just 0 and 1. And then we subtract that
Right.
from-
Yeah.
More than or equal to, right? Did I do that right?
Yeah, more
I
than
did
or
it.
equal to,
Yeah,
so
I
it's
did it.
0 and 1.
Yeah. So that means we're going to go equal, right? 1 minus, and I'll put a bracket here, right? I'll put everything in here so you can see it. So it's probability of, now you could have done it the other way too, right? 1, 2, 3?
Yeah.
Or 0, 1, 2? You should get the same thing. Yes.
It's just like faster to do it this way.
You like it this way too? I like it this way too. And you take off 1 and you cut off the chaff, right? There's the wheat and the chaff. Okay, you get it. All right. So this one here, that I've taught a lot of wheat classes. Sorry. X equals 0. And then remember, this is going to be plus inside here, and then it's going to be minus. You guys are pretty smart on this. P and then X equals 1, right? All right? And I agree with, okay, she's right. Just why complicate it further? All right, I'm going to go here, okay? So here we go, right? 1 minus the monster here, right? E to the what? Negative 1.8 times.
Times 1.8
To the?
to the 0.
Good. Over?
0.
0 factorial.
Good.
Ooh,
0 factorial.
that's a no-no.
That's a 1.
Uh-oh!
One.
Wednesday, Thursday, Friday!
Somehow.
It's the 1.
Uh-oh. Guess I prepared today, huh?
When's that?
Well.
Oh, I know how to do that.
Wait.
Good.
I know the proof. I know the proof.
Okay. Why?
WTF.
Why?
0 factorial.
0 factorial.
Yeah. Just magic, right? Okay. Plus, in this case, let's keep going. E to the negative 1.8 times 1.8 to the what power? Over 1 factorial.
Why is 0 factorial 1?
I was waiting for it. Uh-oh. Hold on, Billy. I have it somewhere. I have it. Oh, yeah, I got it.
Did you see the number file on it?
Yeah. I know. They do it by definition, okay? They do it by definition, but that's fine. All right, so far so good? So you're going to go 1 minus the damage here, right? And to fill this out, it's going to be 0.16529. Just Gary. And your data, your thing, no, it will work out that way because we don't have to use the table, the evil Cambridge table, 0.29753. And then it comes out to roughly 0.537, 53.7%. So there's a chance of Sammy observing 2 or more, right? Pretty good. So that hospital's cranking out the kids. Okay? Right? Well, 54% chance, right?
Yeah.
Now they do that stuff about women having births. You know, I observe someone, and what's the chance of that person having a birth? or whatever, you know, or the next, or the certain, hopefully at a certain yearly interval, not like, you know, some broodmare, okay? But they actually used it for other types of species too. They did. All right, not bad. Is it looking okay?
Mm-hmm.
Anybody need a value yet? Okay.
Not good.
Nobody. Yeah. Don't take that diazepam. It's benzodiazepine or bad. Right?
What does that even mean? What's the benzodiazepine?
Oh, it's a class of drugs that is used for anti-anxiety as well as.
How do I guess?
You need a prescription from a healthcare provider.
You're almost a doctor, right?
Depends upon what you think a doctor would be. I know one that can write.
You're almost a
Yeah. Jones and already, huh?
Your
Yeah.
handwriting looks about ready.
Oh, yeah, you'd be surprised at stuff I read. Okay? All right, so it comes out to 54% or 53 point something.
Yeah.
These aren't that bad, right? And I will tell you, because I'm just that way, using the Poisson distribution, or I might say PD,
Mm-hmm.
okay? But the other ones, the BD and the ND, I won't say a word, okay? I won't say a word. They're not that bad, okay? All right, slow down. Any questions? How much time I got? I want to prove the thing here.
You've
What do
got.
I got a half hour?
Here's another time.
Oh, she's like, you have no time. She's like, I got to catch up.
15 minutes.
All right. Now, Billy's going to try to prove the other way using the definition that we did on number 5. All right? Now, someone, Mr. Tribble asked, right, what is,
Why?
well, why is 0 factorial
One.
1? It's like, you know, more of a definition than anything else, but I'm going to try to prove it. Okay?
It's like 0 power.
Yeah. Yeah. I'm going to erase this section here, okay? Oh.
You have
Actually, I'm
one
going to erase this.
of that thing.
Well, it's on video, so if someone didn't get it.
Yeah. Oh, well, I have to keep everything here, right? All right, so
Bless.
just for fun, right? Does everybody believe that n factorial is the following?
Let's see.
Yes.
Right? So using
Yeah.
the definition that they used on number 5, and I'm going to do another one called the gamma function. Okay? So 5 factorial will be 5, 4, 3, 2, and we don't omit the 1 because we don't care about the 1 because 1 times anything is itself. So can we just say for arbitrary sake, let's write 4 factorial as 5 factorial over 5.
Yes.
Mm-hmm.
Yeah.
So that's 120 over 5, right? And that's 24. Well, that works. Keep moving down, right? 3 factorial, right? And you can use the exponent rule too if you want to, right?
4 factorial.
4 factorial over 4, right? And that's 24 over 4, and that's 6. 2 factorial, yeah? 4, and that's going to be
3 factorial over 3.
3 factorial over 3, and that comes out to be 2. 1 factorial is 2 factorial over 2, which comes out to be 1. Now 0 factorial using the same methodology.
1 factorial.
1 factorial
Over 1.
over 1
Is the reason
is the
why.
reason why, and then you go QED.
Yeah.
But you can argue also then that 1 factorial is then therefore 0 factorial over 0, hence, no go.
Yeah.
Why can you write
Because you're
that?
saying
So
that.
we don't know why 0 factorial.
Or I should say negative. I mean, if I went to the next, negative 1.
Yeah.
That's why it's not in factorial, negative, you don't use it.
Sounds like that.
That's just a very, very simple definition that they did on number 5. Slick. I call it a slick definition. Okay?
It makes sense to anybody.
Yeah, of course, you're like, oh, that's nothing. Mr. Upper, you had your hand raised.
Oh, so it's saying you just add 1 to whatever the number is?
Yeah,
put
you add
that-
1 and then divide by the base. Okay? Now, I'm going to hopefully... Now, they did something else about, you know, penny, nickel, and dime. I wish I had the chance to do that, but I'm going to do one other thing here, and then we'll practice on this stuff here, okay? I have a whole boatload of y and so on, but then I wanted to practice, for some reason, what I remembered about the gamma function, okay? They talked about the gamma function also in... They talked about the gamma function also in the number file as well, okay? So the gamma function is just a fancy way of what they would do is they would just graph something like this. They would have n and f of n, the factorials. And what happens is you'd have 0, 1, 2, right, 3 factorial, right? And then so on. What happens is it's going to do this. It's going to be 1 here, and then another one, and then another one. And then it explodes. So what they do is, whoop, they do this, and this value right here is 0 factorial gives me 1. Okay? Similar to a natural law, right? E. So that's graphically. But then they did it by determining it as also using the function here, okay? I need more room. And then I'll shut up and I'll let you guys work with it. They call this thing, using like for greater factorials, you know, they call it what's called the gamma function, okay? Okay, the gamma function. You don't have to write this down, okay? Maybe it's an extra credit question. So the gamma is this one right here. And I'll use T for my variable. We're familiar?
Uh-huh.
So you would put a number in here and then like a large number and get a factorial out.
I think it's integral.
So if I had the gamma, let's say this gamma, capital gamma, okay, of 1, that means I'm going to get 1 minus 1 factorial, which is equal to 0 factorial. And that's equal to the integral of infinity to this guy, t to the 1 minus 1, put it inside, right? E to the negative t dt. Now I start massaging it, okay?
That's the gamma function?
Yeah, the gamma functions are right here. I had to derive it for another comp. I had such a wonderful guy. Let's get my master's.
What about the X-ray function?
X-ray function?
Gamma ray, X-ray.
Of course it's a joke. I should have picked it up. I was being too literal. All right, so to keep going on with this thing here, okay? In order to do this as an indefinite integral, because that's an infinity and so on, that means we have to take the limit as, let's say, just b approaches infinity. Hard to see. And I'm going to go from b to 0 of 1 e to the minus t, and in this part right here, right? Because t, 1 minus, this disappears, right? Because if t disappears, because 1 minus 1 is 0.
Yeah.
Emily's like, I'm going to kill myself, okay? All right, dt. Then I'm going to say the limit using the integral function as b approaches infinity. You'll learn this later using L'Hopital's and everything else. Negative e to the negative t, and I'm going to evaluate it from b to 0. Now the reason why, because you can't do an indefinite integral, right? As infinity bounds.
Yeah.
Sounds familiar? Yeah, you got to do something. You got to throw a limit in there, right? So when I do that, then I just arbitrarily took a b. I could have took a Sandy cat for a dummy variable. It doesn't matter, right? And so remember the t disappeared, right? So anytime you take the derivative of an e to a power, it's just that e to the power plus c, right? But since there's no c needed here because it's not a definite, now it's a definite integral because I have the bounds.
The A and the B.
So now I have the b, right? So that means I'm still going to write the limit as b approaches infinity. I did this. I can't believe I already did this. So here we go. I'm going to throw the things in there, right? And that's going to be 1 over e to the 0 minus, I believe, a negative e to the 0. And then this whole thing, 1 cancels out. So this comes out to be 0 minus a negative 1. And that comes out to be 1. Therefore, funny looking dots, the gamma function of 1 is equal to 0 factorial, which is equal to 1, because I said x minus thing right here, and that becomes
0
factorial. Hence, 0 factorial must be 1. I know what, I know, I don't get out of that. Right? Yes?
So what is that stuff you look like L sub 1 M? Is
So that's a 1 here. That's a 1. It's hard for me to write because I don't want to write, I don't want to take all this down. That's just me.
And how did the Mr. Murmer?
That's it. Here, boom.
Yeah. How did the infinity become B?
Because b approaches infinity. You throw in a dummy variable there. Because I'm not going to use L'Hopital's yet. You will learn L'Hopital's. This engineer.
So
I wrote it down and I don't
what college level will we learn like stuff like
My opinion, with me or with
like normal,
normal humans, right?
like standardized, like.
My opinion, you should know some of this at least in Calculus 2. Depends if they get to this. But if they don't, then it's easy C-year math and a review for a comp for mathematics and graduate. Okay? I just want to show you that you can do this. Yes, ma'am.
We do a normal distribution.
Yes, we will. We're going to do the packet in a second, if that's what you want. Yes, ma'am.
Well, it's a problem I saw online.
Okay. Yeah, let's see. You guys will tell me how much time I have. And hopefully, I saved, I think, the monster amount of stuff you gave me. Right?
Mr. Murmer?
That's me.
So then, like, we have problems like this to do? That we just,
No, God, no.
So this is just like something that you want to
FYI.
introduce to us?
Yeah, if you go into math and engineering, you're going to be like, oh, thank goodness, this guy is crazy person. Okay? Now, I went through it real fast, but I wanted to prove to you that 0, like Mr. Tribble said, how on earth did you know that 0 factorial is equal to 1? And there are multiple methods to show it. I think someone asked me that last year. And
Yeah,
then
it was me.
It was you, and then, yeah, and I said, hold on, right? And then I went and I talked to the cat talked to me, and then I got it, all right? So that's there, and so on. All right, I got about, I don't know, 10 minutes, 15 minutes? 10 minutes.
Yeah.
Less than 8.
So, 8. All right, I will let you guys do your own devices, okay? Meaning if you don't like yell and scream and everything else, that's fine. There is the packet that I gave you. I'll have to find it here, because this 1 through 21 only deals with practice problems of normal as well as a binomial. I will get you tomorrow the Poisson. Okay? I want you to show you that it's very important. At least in math. I think everything's important when it comes to math. But you're able to do it and then to get it. So what I would do is I'd work on some of these, and then Eileen's going to come over and then we're going to talk about one of them. So I'm going to leave for the last 10 to 12 minutes. You guys hopefully work together on this. All right? Yes, Mr.
So, 2 questions. So then, we need to turn that into for a grade,
No.
and then
No,
the
you
other.
don't.
So, like, we have a test like on the
Next
normal
week.
and binomial.
Normal, binomial, and Poisson.
Okay.
And then I got to cover some other new stuff. And I will give you a review for